Al-Marifa International Private School, IGCSE Physics 0625 Thermal Physics. Learning Objectives 211 States of Matter. Core State and Distinguishing Properties of Solids, Liquids and Gases. 212 Molecular Model. Core describes the molecular structure of solids, liquids and gases in terms of the arrangement, separation and motion of the molecules. Explain the temperature of a gas in terms of the motion of its molecules. Describe the pressure of a gas in terms of the motion of its molecules. Show an understanding of the random motion of particles in a suspension as evidence for the kinetic energy molecular model of matter. Describe this motion, sometimes called a Brownian motion, in terms of the random molecular motion. Supplement. Relate the properties of solids, liquids and gases to the forces and distances between molecules and to the motion of the molecules. Explain pressure in terms of change of momentum of particles striking the walls, creating a force. Kinetic energy theory. The symbol kinetic energy theory is used to explain the properties of solids, liquids, and gases. The main statement of this theory that all state of matter, the properties of all state of matter that are in a continuous motion. All matter is made up of tiny particles. The diameter of each particle is 10 power of -9 meters. Each particle is called molecule. These molecules are in a continuous motion, and they are attracted by a strong bond if they are close to each other. They have kinetic energy because they are in motion. As well, they have potential energy because they have attraction force between them. They are separated by a small distances called intermolecular distance. Now we are going to distinguish between solids, liquids, and gases in very simple way. In shape, solids, they have fixed shape, and liquids, they do not have fixed shape. As well, gases also do not have fixed shape. So as you see, in solids, they have definite shape. Liquids and gases do not have this definite shape. Now the second simple property, can you pour? In solids, they don't have this property. Liquids and gases, yes, they can. Can you stir? In solids, no, you can't. In liquids and gases, yes, they can stir. Can you squash? In solids, no, they don't have this ability. In liquids and gases, yes, liquid and gases, they can squash. Now the differences in details. Look at the molecules of gases and their arrows. They are tightly packed, they have regular arrangement, and they are vibrating in a fixed position, since they have very strong bond between them. See, these arrows represent the vibration of each molecule in same place. Look at the molecules of liquids. They are also tightly packed. They don't have regular arrangement. The molecules of liquids, they can pass over each other. They don't have fixed position. They can move in same container. See these arrows of liquids to represent the motion of liquid particles or molecules. Now gases, look at the arrows of gases to represent the widely space between one molecule of gas and other one. The longer arrow here also represents the motion of particles of gas. Their motion is freely, randomly in all directions, since they have high speed. The bond between each molecule and other one is very weak. In solids, the particles or molecules, they are vibrate about a fixed position within a closed packed regular structure. The particles cannot move in between each other, which results a solid having a definite shape and definite volume. Liquids. In a liquid, the particles or molecules move in between each other and are approximately the same distance apart as solid. A liquid does not have definite shape, but it does not have a fixed volume. So it has a definite volume, but not definite shape. In gases. In a gas, the particles molecules move in between each other and are much farther apart than they are in liquid. A gas takes up the shape and volume of its container. Change in state. Solid can be changed into liquid, and liquid can be changed into gas, and this is represented by this arrow upward. Gases also can be changed into liquid, liquids can be changed into solids, and this is represented by this arrow downward. The change in state from solid to liquid is melting. The change in state from liquid to gas is boiling. Also, there is other change, we will explain this one later on, called evaporation. The change in state from gas to liquid is condensation. The change in state from liquid to solid is freezing. Through the change in state, the solids of particles, they have fixed position. They are fixed in a place and cannot move. In liquids, the particles are free to move, but within the container, inside the container. But the gases, they are freely to move in all directions, even out of the container. Now solids. Look at the molecules of solids. How the molecules or the force is strong, attracted between each other. So they have strong forces of attraction. They are held in a fixed position, in a regular arrangement, and the particles vibrate in same place. So that's why they have definite shape and definite volume. Now, when the particles of solid become hotter, the particles vibrate more. So they can expand, but they cannot be compressed. When you heated a solid, the molecules gain more of energy, so they will vibrate more. Strong forces are overcome. Molecules start to move, and will change the solid into liquid by melting. Liquids. Look at the molecules of liquids. The intermolecular force is weaker than solid. The intermolecular distance of liquids is more than solids. So they don't have definite shape, but take the shape of containers. Molecules are continuously in motion, but inside the same container. When you heated a liquid, they will move faster and also they can expand. But the molecules of liquids, they cannot be compressed. Heat makes the molecules move faster as they gain energy. Fast-moving molecules at the surface will overcome forces of attraction and escape, and this is called evaporation. In gases, the intermolecular distance is more than in liquids, and the intermolecular force is weaker than in liquid. So they are the particles, they are freely to move and they travel in all directions in straight lines. And also they sometimes collide with walls of container. So they don't have definite shape, as well they don't have definite volume. And they can expand to fill the container. Exert a pressure on wall of container, they continuously moving in a random motion. Move faster when they heated, they can be compressed, and the density of them, mostly, it is low. When you heat some particles of gases, the molecules, they have enough speed and energy to overcome spaces and escape from each other. molecules break away in a big bubbles of gas, and this is called boiling. Summary of a state of matter, solids, liquids, and gases. The summary for solids. The molecules are held in place by strong intermolecular bond. This is number one. These bonds prevent the molecules from moving, giving the solid its rigid shape and fixed volume. In liquids, the molecules have enough energy that they are able to break the bond between them. The bonds are still there, but they no longer hold the molecules in place. As a result, the molecules can move around by sliding past over each other, allowing the liquid to flow. In a gas, the molecules are now moving around randomly at high speed. The molecules have broken the bonds between them. They are widely separated with no longer range forces binding them together. As a result, the molecules are able to move freely, and so the gas can flow freely. Because of the large spaces between the molecules, along with the absence of long-range forces, the gases can easily be compressed and is also able to expand. This is the summary of all characteristics of solids, liquids, and gases. Now, so what evidence is there for moving particles? The evidence for moving particles is called Brownian motion. Brownian motion, as you see, we have here the microscope, and this microscope, suspended under this microscope, a slide. This slide is made up of smoke and gas. And here we have the light resource. Now, the suspended slide inside will be viewed by this one. See this one. This one shows us that the particles of smoke are moving in zigzag path of motion, zigzag path of motion. This is the viewed slide from this side, from the side of the microscope here. Now, the explanation. As you see here, the slide here is made up of smoke particles and also of air particles. Smoke particles reflect the light falling on them. So the smoke particles reflect the light falling on them and are seen as bright specks against a dark background, moving in a random motion in all directions. Now, as you see here, that the smoke particles reflect light falling on them, and this is the shape of the smoke particles motion. Now, the much smaller the explanation of this motion, Brownian motion, the much smaller and much faster air molecules collide with the large smoke particles in a randomly motion from all directions, and this is cause the smoke particles to move randomly. So as you see, this is discovered by Robert Brown in 1827, and they call this effect by Brownian motion. So, as you see here, the smoke particles reflect again the light that exposed from this side, and they appear in this shape. The explanation of the Brownian motion that the air particles that are moving in a high speed start to collide with the smoke particles, and this colliding is in a random motion in all directions, which cause the smoke particles to move randomly in high speed with zigzag motion, as you see here. And this is discovered by Rupert Brown, 1827. Now, so the connection with the kinetic theory can explain the Brownian motion. The particles of smoke, they collide with small tiny particles, which is the air particles that is already suspended inside. And this motion of the particles of air affect to move the particles, big particles, which is the smoke, in this shape of motion. So as you see, the particles, they start to move in a small straight lines, then change the direction in other small straight line, then change the direction in other small straight line. So this is the Brownian motion. If the cell of the smoke is heated, air molecules move at higher speed. The smoke particles would move faster. Due to faster motion of air molecules hitting them, and also the Brownian motion, the zigzag motion will be more. So heating up again the slide will cause the motion to be more fast. Internal energy. Particles of solids, liquids, and gases have kinetic energy because they are in motion, and also they have potential energy because they have attraction force between them. Now, the ordering of decreasing the potential energy, first, the highest potential energy will be for solids. Second will be for gases. Second will be for liquids. Third will be for gases. For potential energy, the particles of solids, they have the highest, then particles of liquids, then particles of gases. Now the total kinetic energy and potential energy of atoms and molecules in a material is called internal energy. Now the hotter a material, the faster the particle moves and the more internal energy it has. If a hot material is in a contact with a cold material, energy is transferred, and this is called heat. The hot material loses internal energy, the cold material gains internal energy. Also, the term of thermal energy is also used for both internal energy and heat. So we can say internal energy or thermal energy. Now, gases and pressure. Now, kinetic theory tells us that gases consist of very small particles that are in a continuous motion and also in a completely random direction. The particles have mass. Now, so whenever they collide with something, they exert a force on it. In a slide container, gas particles will smash against the walls of the container, creating an outward pressure. If the same amount of gas is put into a bigger container, there will be fewer collisions with the walls of the container, so the pressure will decrease. If a smaller container is used, then there will be more collision with the walls as the particles are being squashed closer together. The pressure will increase. As the molecules move around, they collide with the surface of the walls. Each collision applies a force across the surface area of the walls. Pressure is the force per unit of area. So pressure is equal force over area. The pressure will be exerted on the walls. Molecule and momentum. When molecules collide against a wall, they bounce off, change their momentum, as you see here and here. When molecules in a gas collide against a wall, they undergo a change in momentum. So toward the wall, positive mv. From the wall, negative mv. So there is change in momentum in this case. There are many such collisions every second, resulting in a large change in momentum each second. This change in momentum each second results in a force being exerted against the wall. So the formula F equal mv minus mu over T. The pressure exerted by the gas is equal to this force divided by the area of the wall. Gas and pressure. The volume of a gas is inversely related to its pressure at a constant temperature. As the volume gets bigger, the gas pressure goes down, so they are inversely related to each other.